going to paste it, and I most likely will record this session and then post this question for the people who haven't attended. Okay, so here when you guys are looking at the fact that this is two different functions, you want to, again, analyze, is this basic integration? It's not. Is it U substitution, which is going to get very confusing very soon when we see all the problems mixed in together. This is not U substitution because you guys cannot let U be equal to something and expect its derivative to be somewhere within the integrand for it to cancel out. So that's your analysis. You should check those two before you do integration by parts. And then hopefully you'll get to a point where you see, okay, well, this is exponential, this is trig. In my ILATE acronym, I would see that T and E are interchangeable. And I can let U be equal to whatever I want, either 2x or sine of x. When I think about taking the derivative of one thing and then taking the derivative or taking the integral of another, I would guess that it's easier to integrate the exponential function than it would be to integrate the trig function. So I'm going to go ahead and set dv be equal to e to the 2x dx and u be equal to sine of x. At this point, you guys can let, again, u be equal to either the trig or the exponential function. So if you already started this problem and you reverse the two, we should end up with the same answer. Okay, so on the left, you guys integrate and you get sine of x is cosine of x dx derivative. If you integrate the right, you guys get v equals e to the 2x. So this even as subtle as it is technically a u substitution in your head because you guys have something other than x there. So when you integrate e, you notice that I'm only doing reverse u substitution in my head if the baby function is linear. So I can't do this if this is like e to the x squared or e to the x cubed, only if what you have in the baby part is linear. And then when I check my work, the derivative of e to the 2x is supposed to be e to the 2x times 2. So when I'm doing an integration problem, I want to undo that. So I want to multiply by the reciprocal of 2, which is 1/2. So that might be where some people dropped the constant and therefore the answer was slightly different. So here we go. So we are now going to rewrite e to the 2x sine of x, the original problem, as uv. So uv is 1/2 e to the 2x times sine of x minus the integral of v. As you guys do that, just feel free to pull out the constant so you don't have to think about that as another step. V du, and du happens to be cosine of x. Okay, we see that we run into the same problem again, where this part right here is exponential and trig. So we're gonna do another iteration of voodoo. Keep in mind, you guys have a 1/2 out front. So we will let u be equal to, and I'll switch colors for this. So this part of it, I'm going to do in blue. I'm going to keep it the same thing. I'm going to let my u be equal to the trig function, because again, I'd rather take a derivative of a trig than an antiderivative, and dv be equal to e to the 2x dx. So rinse and repeat, right? du is equal to negative sine of x dx. Integrate the right, v is equal to 1/2 e to the 2x, same reasoning. Okay, so I'm going to keep in mind that all of this is where you guys want to be careful. All of this is out front still of my integral. So I'm just going to rewrite that. 1/2 e to the 2x times sine of x minus 1/2. And then here comes the other voodoo part. You guys have uv, which is 1/2 e to the 2x cosine of x minus v du. So the integral of v, which is 1/2 e to the 2x times negative, so v du, so you have a negative sine of x, so I'll just keep the sign there. All of this was equal to e to the 2x sine of x dx. So here's what should always happen every single time you guys do this, is by this time you do the second iteration of voodoo, you should have gotten back to some form of the original. Okay, so when you get here, double check your signs. It should always happen such that when you distribute this -1/2 to this tail end of the voodoo part, you're going to get a negative times a negative times a negative, which is negative. So that's where sometimes we drop a sign here and we make a mistake on that. So they're just going to rewrite that really quickly. So I'm going to distribute the -1/2 to get -1/4 e to the 2x cosine of x minus 1/4 e to the 2x sine of x. And again, that triple negative is going to result in that -1/4. What coefficient is in front of here? What coefficient is in front of that? Anyone know what's in front of that? Yes, you guys have one of those. So that means that when you add the 1/4, you have, it's like 1/4 x on this side, and then you have 1x on this side. So we're going to combine like terms by adding, and your like term right now is the integral. So you're going to add 1/4 to the other side and get 4/4 plus 1/4 is 5/4. And then I always just add my plus c at the end. But let's say you guys have this, we're still writing out our antiderivative, so I'll add it at the very end. To get rid of the 5/4, we would multiply by 4/5 on both sides. So you have a 4/5 out front of all of that, and then the plus c at the end. And that's your whole antiderivative right there. For the person who asked, I forget already. Does that make sense?